So today we'll be talking about finding the equation of a tangent line to a space curve. How do you do that? Well, let's first make a formula for a space curve. So these space curves are going to be vector valued functions. So we're going to have a vector as the function. Let's make something up. 3t plus 2 sine of t. Sine of t, that's going to be annoying to do. I can already tell. T to the power of 3 t. And we're going to try to find the equation of the tangent line at t equals, let's say t equals 1. That's an easy number to solve for. Okay, how do you find the equation of a tangent line at t equals 1 given this space curve here? So, first thing you have to do, you have to find velocity. Because velocity will give you the, I guess, what was it? The slope of the tangent line. Yes, that's the word. Oh my god. The slope of the tangent line at the space curve, r, right here. And once you have the slope of the tangent line, well, not necessarily the slope, but the vector that is parallel to the tangent line at t equals 1, you can actually use the equation of a line, a vector equation of a line. Very old fashioned, but I don't know if you remember this, but it's x null, y null, z null plus t of x, y, z. And x, y, z is the vector that is parallel to a line, and x null, y null, and z null is the values of any point on that line. So, what do I mean by that? Well, let's do the problem and you'll find out. But first thing you have to do is find the velocity. So the velocity is r prime, derivative of r, so we find the derivative of all the components of here. The derivative of this is 3t squared, and 1. Now that we have that, we can actually plug in, we can plug in 1 for t, and then we get 3, 3, and 1. This is the vector that is parallel to the tangent line at t equals 1. So we're going to use this vector, we're going to put it into here. Then let's plug in r of 1 so we can get a point on that line. So the next thing that we do is find r of 1. We just plug in 1 for the position equation, and we get 3 plus 2, which is 5. And then we get 1 to the power of 3, which is just 1. And then we get t, which is just 1. Well, what do we do here? All we have to do is plug this in. This point right here, r of 1, is a point on the tangent line. So we can actually use this equation here and plug in the values that we got into the equation of vector equation of a line, like this. And if you do that, you get 5, 1, 1, plus t, 3, 3, 1. It's not too bad, right? Let's move on to another problem. Let's use sine of t, cosine of t, and t. This is a classic spiral for space curves, and this will be our r of t. And we're going to find the tangent line at pi. So what do we do here? Let's find the velocity equation. The velocity equation is just a derivative of all the components of the position function. So derivative of sine is cosine. Derivative of cosine is negative sine of t. Derivative of t is just 1. So let's plug in pi for the velocity function to find the vector that is parallel to the tangent line. And when you plug in pi to cosine, what do you get? Negative 1. Pi to sine is just 0. And pi to 1, you can't plug that in, so you just get 1. Now all we have to do is plug in pi for r. So pi into sine is again 0. Pi into cosine is negative 1. And pi into t is just pi. All we have to do is just plug these values in to the vector equation of a line, the first vector here is typically the one of any points on the line, and then the second vector is multiplied by t, and this vector is any vector that is parallel to the line. So this is our answer. This is the equation of a vector, like vector equation of a line that is parallel to this space curve at t equals pi. Let's keep doing more. T to the power of 3 plus 2 negative sine of t. Let's just make this like kind of difficult. What else is there? What else can I do with this? I don't know. Square root of 2 t squared. Nah. Negative t to the power of 6, I guess. So this is equal to our position function, and we're trying to find the equation at the line, the vector equation of the line at let's put 0. Yeah. So what's the velocity function here? Find the velocity function. Derivative of everything here. 3t. Derivative of negative sine is negative cosine t. And derivative of t to the power of 6 is negative 6t to the power of 5. We plug in 0 for velocity, and then we just get 0, negative 1, and 0. So this is our vector that is parallel to the line that we are trying to find. And we plug in 0 for r. What do we get? 0 for r is 2, 0, and 0. So all we have to do, put the point first, and then we put the vector that is parallel to this line multiplied by t. And this is our equation again. It's not that bad, right? It's just finding a derivative and plugging things in. It's mostly understanding the concept. That is the hard part. But once you set everything up, you got it. You're all good. Okay, so last question. Yeah, this concept isn't that bad. It literally just either takes hard work to practice this, or you understand the concept and you never have to memorize any formula ever again for it. But let's find this at t equals 1. So let's find the tangent line at this space curve at t equals 1. So first thing we do, find the velocity function. This velocity function is just the derivative of the position. So we get 1 over t for the derivative of ln of t. And then we just plug in 1. And then lastly, we find some point on this tangent line and what other point to use than the one that intersects with the space curve. And the one that intersects with the space curve is on the space curve at t equals 1. So r of 1 is 1. So you plug in 1 squared, 1 here, and 1 here. ln of 1 is just 0. And all you have to do is fill in the values of the vector equation of the line. And again, this first, let's use green. This first is any point on the line. And what other point to use than the one that's intersecting with the space curve? Because remember, tangent lines intersect with whatever it's tangential to. And this one is the vector that is parallel to line. And the vector that is parallel to this line is the velocity. Because what does velocity find? It finds the slope in the case of single variable calculus, but it finds the, I guess in the case of calculus 3, it finds the vector that is parallel to the line that is tangent to the space curve at that point. So if you have any questions, put it down in the comment section. Hope you learned something.